Hello everybody, welcome back. This video is about calculating probabilities. So let's start with the very basics. Just to refresh your memory, so if you want to calculate the probability of a generic event A, one way to go about it is to simply count the number of elements in A and divide this by the number of elements in your sample space omega, and this would give you the probability of A. Now, a consequence of this is the following facts, which you could see at in the bottom left corner of the slides, namely that the probability of any event A or any generic event is always going to be between two values, between the value 0 and the value 1. So a probability can never exceed the value 1 and can never go below the value 0. You can also express probability using percentages, and so in that case the lower bound would be 0% and the upper bound would be 100%. So probability can never go below 0% and can never go above 100%. So another interesting consequence of this is if we were to ask the probability of omega, so the probability of the event corresponding to the entire sample space, and that's defined again as usual, so it's a number of elements in omega divided by the number of elements in omega, and you can see just mathematically that this is always going to be 1 or 100%. So if there is an event that is like the event corresponding to the entire sample space, that event has a probability of 1 or a probability of 100%. Here is a very simple example if you're wondering. So let's consider the tossing of a coin. In that case, the sample space can be represented by two outcomes. Either you get heads or you get tails. So you have two outcomes in the sample space. So the sample space contains of two elements, and now you ask yourself, what is the probability of the event that I get heads or tails? Well, that probability is simply 1 because that's the event that encompasses the entire sample space. Okay. Next, here we are interested in the probability of the complement of A. And so remember that the operation of complement is the operation that describes, that picks out all the elements that are not in A. So in here, we simply need to count the number of elements that are in the complement of A, so namely the number of elements that are not in A, and divide them by the number of elements of omega. An interesting fact about the probability of the complement is that it is the same as 1 minus the probability of A. And you can verify that by thinking about this a little bit. But from the picture, this should be fairly clear. Now next, we want to know the probability of A intersection B, and again we apply the same method as before, so we would need to count the number of elements in A intersection B and divide it by the number of elements in omega, which is our sample space. And so pictorially, remember that the intersection is that operation that picks out the elements that are in common to both A and B. So that's the area that is circumscribed by the thick black line that I drew. That's the intersection of A and B. So we count the number of elements within that area, and then we divide it by the total number of elements in omega, our sample space, and this gives us the probability of A intersection B. We can do the same with the union, so we can ask the probability of A union B, and this is again going to be the same. We count the number of elements in A union B and divide by the number of elements in omega, which is our sample space. And keep in mind, pictorially that the union is this operation that picks out all the elements in A and B, not just the elements that are in common. And so that is why pictorially I drew that thick line around both A and B. Now, what is interesting here is that there is a way to calculate the probability of A union B from the probability of A and the probability of B individually. So supposing that you already know what the probability of A is, and you already know the probability of B, you can calculate the probability of A union B simply by adding the probability of A plus the probability of B. So this is very useful when you want to calculate probabilities. But this rule only works if the set A and B, which are a collection of objects, as you know, do not overlap. So this means if they do not have any element in common. And so that's a possibility. And so you see I represented them graphically as separated from one another. There is no overlap between the two. So this means that they don't have any element in common. So you can think, for example, the set of A as the set consisting of the number 1, 2, and 3, and the set B as the set consisting of the number 25, 50, and 80. So you see that these two sets don't have any element in common. But what if the two sets overlap? Can we have a way to calculate the probability of A union B from the probability of the set A and B when they overlap? There is a way to do that, but what you'll have to do is to add the probability of A to the probability of B, and to that sum you need to subtract the probability of the intersection of A and B. And why is that? Well, because if A and B overlap, so there is an area that they share, so they have some elements in common, when you do the addition, you and don't subtract the area corresponding to A intersection B, you are going to double count. And you can check this for yourself by looking at the picture. So if you simply were to add the area corresponding to A, so that's what represents the probability of A, then you were to add B, you would basically count the area that is of overlap between A and B twice here. And that is why you need to subtract the probability of A intersection B, where A intersection B precisely refers to the area of overlap. So just to recapitulate, we have seen a number of properties of probability. So the first property is that the probability of an event A is always going to be between 0 and 1. Probability can never be below 0 and can never exceed 1. Or you can also talk about percentages. So in this sense, in terms of percentages, the probability of any event A is always going to be between 0% and 100%. The second property is that the probability of the entire sample space is always going to be 1. Because that's the sample space represents anything, all the possibility, all the possible outcomes. So there is nothing that is outside of it. Then the probability of A union B is equal to the probability of A plus the probability of B, but this only works if A and B do not overlap, so they don't have any elements in common. And finally, the probability of the complement of A is the same as 1 minus the probability of A. So these are some important properties of probability that it's good to keep in mind.